Hi there. So in this video, we're going to take a look at the first lecture on perfect competition. So we're going to do some review of some of the things that we learned in Unit 3 about theory of the firm, but we're going to try to put it together and show what happens if maybe the demand for the product changes or the price changes, given that perfectly competitive firms are price takers. So let's get started. So the first thing to know is that these firms are price takers, right? We might even want to like underline that. And by that, we mean that the firm can't make a higher price. They can't say, gee, I want to charge a higher price for this product because all of their sales would go to other firms. So as a result of that, they just have to accept what the market price is. And so their marginal revenue every time they sell an additional unit is exactly the same as the demand for that firm's products. And so it's also the same as the average revenue of the firm, which is the same as the price. So we have that Mr. Darp. The second thing that's true of perfectly competitive firms is that the marginal cost curve is the firm's supply curve for the range where it's the upward sloping part of marginal cost. So we might just put like a little like asterisk for part of MC that's upward sloping. And that's really just to say that like the downward sloping part, the downward part of the Nike swoosh, that's not part of the firm's supply curve because they aren't willing and able to produce at those quantities. It wouldn't make any sense for them to stop in the downward sloping part of the marginal cost because they can still realize savings by specializing and increasing output. So they wouldn't ever stop in the downward sloping part of the MC curve. So for them, the supply curve technically is only the upward sloping part. Now, the second thing to know is that in equilibrium, a perfectly competitive firm is both allocatively efficient and productively efficient. And those two terms are going to come up a lot in this unit and in the next unit. And it's this idea, allocative efficiency means that we're producing at the quantity where the demand curve is the price. So we're producing a quantity of output where the demand is the price. And by definition, they have to be. The second thing is that they are productively efficient in equilibrium. And that's the idea that they produce at the quantity where they're at the minimum of the ATC curve. And so those are just the two definitions of allocative and productive efficiency. Now, let's take a look at what perfect competition looks like in equilibrium, both for a market and a firm. So take a look here. And this graph, right, is shown for us here. I'm going to draw it and show you kind of the step-by-step way of constructing this graph. So the first thing to do is we're going to draw two side-by-side axes because these two markets are related to each other, right? We've got the market graph with P and Q and the firm graph with P and Q, and the y-axis is the same scale. So we know that in a market, you've got a downward sloping demand curve and an upward sloping supply curve. That market sets a price and a quantity. We'd say quantity equilibrium. And actually, just for clarity, let's put QM for quantity market and PM or PE over here for price. Now, this market price is the price that this firm has to accept. It can't charge that higher or lower price. It wouldn't make any sense to do so. And so for them, the price is the same as the demand curve, the average revenue curve, and the marginal revenue curve. They're all the same thing. And so these are equal to each other. Now, the second thing that we're going to add onto our graph, and so we can put PE here, is the marginal cost curve. It's that Nike swoosh. So it looks like that, marginal cost, and it's equal to the supply curve for the firm. I'm going to put a little sub F here so that you know this is the demand for the firm's products, and this is the demand in the whole market, right? This is the supply curve for the firm, at least from this point upward, and this is the supply curve for the market. Now, the second two lines that we're going to add on to this are average total cost and average variable cost. But before we do that, we can already establish where this firm is going to produce in terms of the quantity. Remember, they profit maximize at MR equals MC. So they're going to produce at that quantity that the firm produces to profit maximize. Now, in the long run, in an equilibrium, we're going to draw down the ATC, hit that little dot, and come back up again. So ATC, MC, and MR are all going to cross at the same point. Three lines crossing in one spot. This is a perfectly competitive firm in equilibrium. It actually means that this firm is breaking even, as we'll see, because the ATC value equals the amount that they're bringing in for that number of units. So they actually have normal economic profit. Now, for the average variable cost, it's going to be below ATC because it's less than ATC. Necessarily, it's a component of ATC, but it's not all of it. So we're going to draw the AVC down here, hit that minimum, right, at the marginal cost, take our pen off, and then come back up again. Now, to be technically accurate, this line needs to be getting a little bit closer to the ATC than over here. If you don't end up doing that, that's perfectly fine. No one's going to get out a ruler and measure the gap. But really, in a true sense, this distance between AVC and ATC should be getting closer, as we learned last unit. Now let's take a look at what happens in the next portion, get the next sheet of paper, when there's a firm shift, there's a market shift that causes the firm to earn a profit. So we already established that in equilibrium, the perfectly competitive firm is earning zero economic profit. It's breaking even. But in this circumstance, we're going to see what happens when something changes to cause the firm to earn a positive economic profit. So this would be a short run equilibrium. It's not going to be in the long run. So we'll draw two graphs. And we're going to start these in equilibrium. So if you like, you could just redraw your equilibrium graph from before. And what I'm going to say is, if you don't want to include the AVC on this one, that's okay, because this one doesn't require an AVC. So we have demand and supply. And we know that it's kind of going across, and it's going to set the Mr. DARP. Demand, average revenue, and price. That way you can see. And this is the demand for the firm's products, Mr. DeFarp. All right. And quantity in the market, price in the market, price for the firm. And then we've got marginal cost, just like before. And we know that that's the supply curve for the firm. Now for this one, we're going to start with the ATC being here, just like that, ATC. And originally, right, this firm is producing QF1. Or just QF, actually, just so we keep it consistent with what's down here. But something happens in the market to maybe cause there to be a demand increase for this product. Maybe people develop a taste for this or a preference for some reason. So there's an increase in demand, an exogenous change that just happens outside of this problem. And so in the market, now there should be a larger quantity, right? And we should see a higher price. So the price goes up, the quantity goes up. What that does over here is it causes Mr. DARP to move upward. So Mr. DARP's going to move up. So I'm just going to put MR1 and D1 there rather than rewrite all of that stuff. But we know that it's also like Mr. DARP number one. It's the second Mr. DARP. So Mr. DARP shifts up. Now, where is the quantity that this firm's going to produce? Well, it's going to produce where MR equals MC, and that new number is here, right? Look for the new MR and look over, and it connects to the marginal cost here. So this firm is going to produce at Q1. This shouldn't be terribly surprising because this is an increase in quantity, just like we expected in the market. We also know that the price increases as well. Now, this is where things get a little crazy. In order to figure out how much profit this firm is earning, we compare the price to the ATC at the quantity where they're producing. I'm going to say that again. We compare the price to the ATC at the quantity where it's producing. So what's the price? Well, P1, right? That's the Mr. DARP, the new Mr. DARP, to the ATC, which is here at this new quantity, right? So we have this dot on the ATC line. And that amount, the vertical distance there, is the per unit amount of the profit. And if we said how much total profit is this firm earning, well, per unit times the number of units. So it's this rectangle right here. So being very, very careful here that we do not go too low, right? We do not connect it back to the old Mr. DARP. That's not, that old Mr. DARP is gone. He's dead to us now. So we ignore that old Mr. DARP. So notice that now we are producing kind of at this little weird spot here off to the right of where QF was. Now that's the profit rectangle. Really, really important to be able to draw that and analyze that on a graph, okay? Now we're going to take a look, and this is just kind of restating that, right? we're going to take a look at this two other scenarios where a firm would be losing money, right? A firm isn't always necessarily earning a profit or breaking even. Sometimes they lose money. And there's two possible outcomes for when a perfectly competitive firm is losing money. Sometimes they're going to earn a loss but still operate in the short run. And sometimes the price has dropped so low that they're just going to shut down because there's so little demand for the product. They'll just say, you know what, we'll close the doors. So we're going to start in an equilibrium just like we did before. So again, if you just want to, if you want to go ahead and redraw that, you can fast forward me or whatever you need to do. You're going to redraw equilibrium. And this, by the way, is also really good practice for you to draw these over and over and over again. So we've got Mr. Darp and the price equilibrium. We have a market quantity, and then we'll move that over just a little bit. We have marginal cost, which is equal to the supply curve for the firm. And we have here, come down, take our pen off, come back up, ATC. Now for this one, we're going to actually need, the AVC. So this one's pretty important. You need the AVC to determine whether the firm should shut down or whether it should continue to operate at a loss. Now the shutdown rule is pretty straightforward. If the price goes below the AVC, then they should shut down. If the price is between the AVC and the ATC, then they should continue to operate at a loss because they'll be able to cover their fixed costs, but not quite all of their variable costs. And so for this first picture, we're going to show a situation where they still operate. So I'm going to say, draw your AVC down here, right? And take your pen off and then come back up again. AVC like that. Now, what we're going to want to do is shift the marginal revenue, the Mr. Darp, down. And so the demand is going to fall, but it's not going to fall too much because if the price goes below the AVC line, then the firm's going to just shut down. So we don't want to get too crazy with our leftward shift of demand here. So I'm going to say we'll just have just a little bit of demand decrease, right? So we've got a new price here and a new quantity. So we see that in the market, the quantity falls and the price falls. Well, what's that do for Mr. Darp? Well, Mr. Darp's going to go down as well. So that's MR1, D1, P1, blah, 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 blah. So Mr. Darp shifts down in this one as opposed to up like it did in the profit. Now at this one, we do exactly the same things we did before. Where is the firm going to produce? Well, and I forgot to put it on the original one. The firm always produces at MR equals MC. So the original MR equals MC was this original Mr. Darp, and that was this dot here. So this was the original firm production quantity. And now there's a new MR equals MC. So the new Mr. Darp is here, and we go over and it's right here where it connects to the marginal cost curve. So this is the new quantity where they profit maximize or they loss minimize. So the firm is going to produce less because the price is lower here, right? They're producing less because the demand shifted. It decreased for their product. And so it decreased for this firm's products as well. Now, we're going to compare price and ATC. Remember, that's what we do. We compare, once we've done this, we compare price and ATC. But where is ATC at Q1? Well, in this one, it's not AVC we're looking at. It's all the way up here, right? Price is way bigger than, or ATC is way higher than what the price is. And that should make sense. The cost is bigger than the price you're getting, so you're going to be losing money. Now, if we connect these to the ATC and the price, that's the per unit loss. And if we then take a look and we see like, well, what would be the total amount of loss? We just draw that over. And we shade. So that's the total loss box. Now this firm is going to continue to operate in the short run because it's able to cover its fixed costs, but not all of its costs. And so it's going to lose money, but it would actually lose more money if it totally shut down. Now the second scenario for where it's here is if the price falls too low, if it goes below the AVC, the firm is going to shut down. So this is one where, and this is kind of the picture we're going to get to, the demand curve is going to shift really far to the left. So we'll redraw here. And again, if you want to fast forward me, whatever you want to do here, you can pause or whatever you need. Demand, supply, supply to the sky. Price equilibrium, quantity in the market. And then we set this old Mr. Darp. And demand, average revenue, price. We draw our marginal cost curve, which is the firm's supply curve. And we're going to draw that original ATC down and come back up, ATC. And now for this one, I'm just going to give you a little tip. If you know the firm in advance is supposed to shut down, then you're going to want to keep the AVC a little bit higher. So put this one here, down, come back up, AVC. So now this firm, we know the firm produces where MR equals MC, right? That's the Mr. DARP and the MC line. So they're in equilibrium, and now the demand is going to drop dramatically for this product. So for this one, we're going to say demand goes nice and far down, demand 1 to this quantity. So quantity falls and price fall. And that's going to push the Mr. DARP really low. So it's going to be below, notice how it's below the AVC line. So this is MR1, D1, P1. So now, if the firm were to produce, where would it produce? Well, it would produce where marginal cost equals marginal revenue. So in theory, it would be producing here, right? Quantity they produce, but they aren't going to produce. They're not going to do that because they actually will lose less money if they just shut down and all they lose is their fixed cost. Now, here's where this is going to get a little technical. If they actually operated, we would compare the price to the ATC. So the price is here, and that would be all the way up to here to the ATC. And if you can kind of visualize, I'm not gonna shade it here, but if you could visualize connecting all of that here, that would be the loss rectangle. But the firm's not going to do that. Instead, what it's actually going to do is just shut down. It's going to lose the fixed cost. And if you remember, average fixed cost is the distance between these two lines, between the ATC and the AVC. So it's going to say, we'll just shut down, and we compare those two, right? We go all the way to that one, and we say, that's the amount of loss. Okay. Now, on this graph, the way I've drawn it, the AVC line happens to just be crossing through where the original Mr. DARP is at that quantity. That was totally a coincidence. I didn't intend for that to be. So if you look at this graph below, it's actually nice and clear where it's like they just lose the box that's between ATC and AVC because that's their fixed cost. That's what they're going to lose. Okay, so hopefully this helped you with understanding perfect competition in different scenarios. I'll see you next time.